We are now in 3.3 summaries for school tuition. Okay, so let's warm up a little bit. Consider a small startup company that has only 5 employees. Okay, so look like we are having a 5 data values, and their salaries. So this data value is talking about the salary, right? As below here. So we have 1,000, and there's a special case with 100,000. So look like could be like one of them, like a manager, big managers, or with like a very different salaries, or because because I did report like wrongly and make a mistake, write out like 3 more zeros, 2 more zero for the salaries of the fifth one, right? So let's take a look at the question. So they say compute the mean salary for the company. So mean salaries, and do you think mean is good representation for mean is good representation of a typical values for the company, right? So for this one, you can either use by StatCrunch or TI-83 to handle this, right? So let me just use TI-83. So open it, right? I'm gonna delete everything here and then click Start, right? Edit, and then I'm gonna put out all the values. 1,000, 1,000, another 1,000, another 1,000, 100,000. Okay, then I delete everything here. Okay. So L1 will be all the 5 salaries of employees here. Okay. I need to find the mean a bit. So click Start, go to Cal C here, and then one via Start, and that's Enter, and you get right away the mean will be X bar over here as 20,800. So let me write down in here. The sum of mean will be 20,000. Let's see. Okay. 20,000. Okay. Oh, 28,000. Sorry. I forgot. 20,800. Can be the correct one. All right. So for the question, say, do you think the mean is good representation representation of a typical value for this company? Well, what do you think? I would say no, since the mean is made extra large, right? Extra large. It's due to the extremely large outliers, which is the 100,000 there, right? So say due extremely Too large outlier is 100,000 there, right? So I mean, even I mean, I expect the mean supposed to be like 1,000 or maybe a little bit different, but you know, because the outlier there is affect the data list to having the mean to be like 20,000 and that's doesn't make sense with the salary for for everyone in this company, right? Okay, so let's we move to the next part. So idea is for school distribution, the mean get pulled to what? The outlier. So the mean is not resistant. So the mean is not resistant to the outlier, right? And the mean do not represent a typical value in this case. Okay, so what we need to do for this guy is using median, okay, to represent the center of the typical values for the school data. Okay, so as you see right now, see this is a dot plot with a school's right data, right? And I have stated that the medians gonna be in the middle here, which is about like 23.5% of the of the fact in the ham, right? So according to the median and above, we can say that the median of a collection data with is have like the better representation of the center. So better representation of center, or typical values for school data. Okay. The median is the middle value. Okay, it's also is a middle value when the data is sorted from smallest to the largest. So data is sorted from the smallest to the largest. Or or the average of the two middle number, because sometimes you have the sample size is even, right? If you have a sample size is odd, then you can easily have only one middle value in the list. But sometimes if the sample size is not even, then you have like two middle numbers, and you have to find the average of it. Yeah. So and also the median will be called at 50 percentile, since 50% of the observation are at or below it. So that is a median. Okay. So maybe I'm gonna try to have like an example for that, right? With the odd and even number. So let's say Yeah, okay. Yeah, susah, right? Okay, so say I have all numbers of data values. For example, such as 2, 4, 10, 13, 17. So you see in here, we have like sample size equal to 5. So the median will be just the middle one, middle median. You might that this one, this the list have been sorted already, so that's why I can just using the middle data values, which is median equal to 10. Yeah. So in another hand side, if we have like an even number of data values, okay, such as like just using another one, say 18. So in here we have 6 data values. Okay, so again, this will be 6 number, right? And you will have two middles numbers, two middle value, which is 10 and 13. So so in order to find the medians, you will have to find the average of this two, will equal to 10 plus 13, and then divide by 2, which will give you I would say 11.5. Okay. And so then you will have the median will be equal to 11.5. Okay. So that is 2 example for odd and even number of data values. All right. So let's pause my actually I'm gonna give you some hint first. So let's do an example 1 here. This is a sample of 6 quiz score from a star class, right? So you need to compute this median by hand. So the first step is always put in order from smallest to largest number, right? So what are you gonna do? So 19 first, right? 20, 24, 27, 28, 30, right? So in here, how many, what sample size do we have? 6, right? So this is an even number of data values. So you have to think about how to handle this in about 1 minute. And then so pause my videos and then check with my answer. Okay, so go ahead and pause it. Okay, so yeah, but I think you guys should have the end summaries. Please compare with mine. So basically in here you have 6 number data values, so you have to have like 2 middle number, and you need to take the average of it, which is the average of 24 and 27, and then it's going to be 25.5 after you calculate it. Okay, so now I'm gonna show you how to use TI-83. I mean, actually, it's the same same way with finding mean on TI, right? So you will go ahead and click on start, calculate, and one VAR start, but make sure that put out the list data list. So 28, 24, 30, 20, 19, 27. So one of the awesome things from TI is you don't have to worry about sorted it for the data values list. And it's actually do it everything for you. You can, you can see that there's some option for you to sort it, but you don't have to do it. You just do calculate and then do one VAR start for L1, and it will just calculate million for you. You will look for it. It's gonna be right in the first in the first output page. You don't see in here at all. You may have to go down, click the down button here, and you will have to go down to MED in here, which is Meddens, and it will tell you 25.5, which is the answer that we have from hand calculator. So we have median will equal to med will equal to 25.5. That's a calculator. Yeah. All right. So what you gonna say for interpret it, right? So interpret a minute. Okay, so the typical of what quiz score, right? Score is 25.5 points for this guy. It's a minute, right? Okay, so that is for example 1. Now I'm gonna move to the next examples. And now in the next examples, we are talking about the data represent for CO2 emission per capita, right? The total emissions in tons divided by the total population. These are just a way to find the total emission. Okay, so this is the data from the countries of Western Europe in 2004. And we have how many data do I have? 1, 2, 3, 4, 5, 6, 7. 7 times 3 is gonna be 21, and plus 22, 23, 24, 25, 26. Total is 26. So n equal to 26. And again, it's even, right? And I don't think it's going to be a good idea to use hand, but the calculators or stack grants can be a good idea for this case, right? So let me show you my calculator first. So stat calculators. Actually, edit first. I'm gonna do 2.34, 2.64, 2.09, 1.34, 3.44. Let me move it down a bit. Okay, 1.64, 3.65, 3.86, 2.07, 2.87, 2.12, 1.40, 1.67, 2.38, 5.22, 2.08, 1.61, 1.47. Make sure that you input carefully because one of them is wrong, everything's wrong. So 2.67, 2.39, 6.81, 1.53, 101, 2.68, 2.21, 1.44. Okay, so this is 26 number, right? And then I wanna find a minute. It's a create histogram and compute median. So let's let's find a median first. Okay, so let's find median first. Calculate 1 VAR and then L1 and the dash. Okay, so we move down a little bit. See the med 2.167, right? You can have right away from TI 83 with one VR stack. We have median gonna be equal to 2.16. Right, you have that? Yep. Okay, so we did have medians. Let's say if you want to have the histogram, you can use you can either go by calculator TI a 3 in here or stack run. But again, for this one, stack run gonna be, I think, gonna be the best for histogram. Okay, but I show you by using calculators also. So I'm gonna click on second and stat plot over here. Click on that. Then you go to number 1 here, just enter that. You highlight the on, right? And you go down to the type, choose the histogram here, and there is, right? Make sure the axlet right now is in L1 because we are using L1. And then you can grab it, but before grab, make sure you check the window. You will have X mean gonna be the minimum number the minimum values of the data in here that you are having. I would say gonna be 1.01. I think that's gonna be the smallest one. So the two 1.01. So 1.01. And then the X max, I would say I saw 5.22 there as the highest, I think. Oh, actually, I see the 6.81 bigger. So when I choose 6.81, you're gonna go farther than that, that's fine. Yeah, you can do like 6.85, something like that. That's okay too. And the scale, I mean, depend on the width that you want. Okay. You can choose one, that's fine. You can choose two. I mean, this is a big width. X scale is big width in this case. Okay. I choose one in here because I think that's really good for this case. If you add one for each level, right? So we move to the Y mean which present for the frequency. The Y gonna be the frequency. So start from 0. I'm gonna say that, and then the max. Well, I think it's gonna be could be up to 10 only, but let's make sure to do 15, and then I grab it and see what happens. Okay, so okay, so we have here the graph of it. Maybe you want to say, oh, what is this, right? How can you see it, right? So you can do chase and see the first one was in between 1.01 to like less than 2.01. So because the width was 1, right? So and we have like 9 data in this range, right? T n of 9. And then we move to the next one, gonna be from 201 to 3.01, and it's about like 12, right? You can move to the one over here, which is about like 3.01 to 4.01, not inclusive. So and the next one over here, there's no one, and we have two other over here, right? One is in between 501 to 601, and the last one is from 6 to 701. So look like we need the X could be like more than 701, or about 701 to about the last one. So let's change the window a little bit to be like 701, 7.01 to make the best. Okay, so you can see now it's better. And if you really consider about like, about the frequency for the Y, you can choose. Yeah, I think 15 is the best already. You see it here. There's one is 12. So let's choose 15 or 13. That's good. All right, so that is by TI, right? You can see the way to wrap to wrap the histogram on it. So I'm gonna show you using StatCrunch for this example later in the other videos. Okay, so let's we just move on to the B. Okay, so all right. So why is median is more appropriate measure of center? So okay, so in this case, In this case, the shape is school, right? Shape is school. So center should be using million, or should be just million. Center should be is million. Okay. So if you see the shape is skewed, you should use center's measurement as millions. Better. Okay, so to interpret the million with the context of this problem, I'm gonna say it's a typical of CO2 emissions per capita, right? Is what is what did I found? 2.165, right? 5, and then units, what is that? Tons per person, right? Okay. All right, so we just finished the example 2, and now let's move to another things in this section. We're going to talk about is interquartile range, right? So interquartile range is how much space of the middles, how much space the middles 50% of that is. So in order to find the IQR, or interquartile range, okay, so we notate it's an IQR here, right? We can first cut the distribution into 4 equal numbers. You can see right now, I cut my my distribution to be into 4 equal number, as you see that 25% and then 25%, right? 25%. Right? So and then you will have to find the median, which is we call is Q2 or quartile number 2. Okay. And I forgot to say that quartiles is because we did cut the distribution into 4 equal numbers of observation. So these cutoff values when we call as quartiles. And then for the medians is going to be quartile number 2 or Q2. And for quartile 1, we use quartile 1 or Q1, the median of lower 50% data. Okay. And the quartile number 3 can be right as Q3 is also a median of upper 50% of data. Okay, so that means what? The range of the middle 50% data will be around in between to this, right? Okay, so we say range middles 50% data, right? Or in the other word we use as IQR. Okay. All right. So the formula for is to find the IQ are going to be just using Q Q2 Q3 minus Q1 as that, right? And so let's do example number 3 below to find the samples of sequence to find the Q1 and Q3 by hand. We have week for sequence score, some of that, right? So so let's start with order. Put it in order. Put that in order. So we can start from the lowest one, which is 19, and 20, 24, then 27, 28, and then 30. Okay, so in here, you have a list with how many data value? 6, right? Okay. So because of 6, which is even data number data values, then to find the medians, you will have to find the average of the middle two number. So medians will be medians will be Q2, which can be 5 as 24 plus 27, and then divided by 2. What is that equal to? 25 5. Yes, that we found it last time, right? Okay, so that means I found Q1, which is a split. That is 3, 50% and 50%. So we're gonna find the Q1 by finding actually delete this. By finding the medians of the lower 50%. Median of lower 50%, right? So that means the list for 19, 20, and 24 gonna be the lower 50% list. I don't know. So let's say lower 50%. Better. Okay. So you will have, what is that? What is the median gonna be? Because this data list now have only 3, right? So this is gonna be the 20, the middle one gonna be the Q1. So we'll say Q1 will be equal to the medians of 19, 19, 20, and 24. Wait, tell me it is 20. So let me put that here. Q1 equal to 20. Okay. And then for the Q3, which is a maintenance of the upper 50%, right? So we'll use so I'm gonna say upper 50% of data. And you're gonna have Q3 will be equal to maintenance of 27, 28, and 30. And you can see that Q3 now can be just 28. All right. Okay, so we did file Q1, Q2, and Q3. Okay. So what do we need? We need to so for part B, we need to well, they said okay, now we're gonna try to find Q1 and Q3 by calculators, right? So let's use TI to handle that. So start, edit. Okay, so I have to put out, maybe I use L3 in this case, because maybe sometime later we have to move back with the bottom above. So let's do L3 in this case as 28, 24, 30, 20, 19, 27, right? Then we're gonna do stat and count C again. Go to one VAR stat. But now I need to put out L3 because I'm looking at the list L3, right? And enter. Okay, so now you have mean and things here, but I don't need it. I have to go down to try to find Q1, Q2, and Q3. Q2 is median, so just remember that. But we need Q1 and Q3 by calculator, so just gonna use say using TI-83 with one VR start. We have output at Q1 equal to what's that? 20. And Q3 will equal to 28. So this is exactly as by hand for it, right? Okay. Okay, so to compute IQR by hand, what you do is just do IQR will be equal to Q3 minus Q1 as the formulas. So you have 28 minus 20s, you get 8. Okay, so that is it. And if we want to interpret the IQR, you're gonna say like the range of the middle 50%. What's the variable in here? Quiz score, right? Score. Oops. Was what? 8 point. Okay, so that's gonna be it. And keep in mind that IQR interquartile range is actually the same meaning as the range of middle 50% over here, right? Okay. All right, so now let's finally come back with example number 4 with using the list in the calculator that I did the list luckily. Okay, so the CO2 emission, right? So let's compute Q1, Q2, Q1, Q3 by your calculators, and please pause my videos and go ahead and try it and check with my answer. Okay, pause it. All right, so hopefully everyone did get into one VS start with L1, which is the list that we are using for the CO2 emission. And you need to go down to the next page to get the Q1 and Q3 is 1.61. So I put down 1.61 here. And 2.68 for Q3. Right. And then QI will be Q3 minus Q1, which is just 2.68 minus 1.61, and you get 1.07 as the answer. And if you want to interpret the IQR in here, you will say the range of middle of the middle 50% of CO2 emissions per capita was 1.07. What's unit in here? Tons per person. Okay, so that's gonna be example number 4. Let's move to example number 5. Okay, so this one have okay, so a lot of things. The following is amount of time each type of employee ate out each week. The first row is for full-time, second row is for part-time, and then for the full-time employees, so let me highlight it. Full-time employees, the millions amount the time the eight week was 4 times. Okay, so we are given million. With IQR is 2 times. Okay, so let's see the part-time. For the part-time employees, the millions is 2 times with an IQR is of 1 time. We want to compare the typical number of time the two group ate out. So okay, so compare, right? So compare. Compare the typical. So millions of full-time employees is 4, right? So say 4, right? And which is greater than the million of the part-time, which is 2. Okay, so millions of the part-time. And the full-time employees typical more, right? More. Each week than part-time employees. So according to the millions, you can say that, right? And for part B, if you want to compare the variability of these two groups, okay, you're going to use IQR full-time to compare with the part-time. So IQR will be for the full-time will be 2 times, and IQR for part-time is only one. So you greater, it's greater than one. Right. So look like the full-time have more time to eat than part-time. Okay, so let's see. Full-time employees eating hour habits vary more, right? Than part-time. All right, so that is about comparing between median and interquartile range. Okay, so now I'm gonna talk about definition of range, which is a distance spent by the entire data set. You can use a formula as a maximum minus the minimum. So range will be maximum minus minimum. You can just need to find the max and then the mean and then subtract max with the mean. Okay, so let's find them. Let's do example number 6 and find the range of the sample. Okay, so we come back with a quiz score again. You can do like all order is, but I mean in here you can easily see that 30 is the max one, right? And we want the smallest one is the mean, right? 19 is the mean. So the range will be equal to the max minus the mean, which equal to 30 minus 19, and that's equal to 11 points. Okay. So that's gonna be it for example number 6. Now for StatCrunch, I will show you later in another videos. And again, we wanna go to my StatLab to do that. And now this is summarize for 3 section from 3.1 to 3.3. So please watch out this. All right. And so these are for 3.1 and 3.3 when deciding on a measure of center, the goal is find the good representation of the typical value. So we try to find a good representation of the typical value, right? For the measure of center, something like that. The decision begin with the pictures first, okay, and the shape of the distribution. Let me use that. The shape of the distributions will. Oh man. So the shape of the distribution will determine the best measure of center to use to communication to communicate the typical value. Okay, so for the school to the left, and you see over here, let me up a little bit. All right. For the school to the left, you can see that the mean will less than the medians in the school to the left, and so you will use centers representation should be median, and the spread should be IQR. Okay. In the other hand side for the school to the right, when the mean is greater than medians, you will also use the center as medians and the spread as IQR. However, for the case that it's a symmetry, right? Symmetry is because like a mount shape or the bell shape over here. In this case, we have mean with equal to medians. So we're gonna use center at mean, okay, and the spread as standard deviation. Okay. And for symmetrics, I mean for below here, let's see, for findings is the mean by hand, you're gonna just average all the data values, right? And for the medians, you're gonna find the middle data values. For the standard deviations, you're going to use all the data values to calculate it, measure 68% of the data values. And for the interquartile range, you're going to use a middle 50% of data values, which is in Q3 minus Q1. So mostly by using TI 83 or TI 84, we're gonna use just one VAR step. Right, to handle that. All right, so I finished 3.3. We'll see you in 2.4 and the video for the stack runs later. Yes, see you later.